Python as a calculator. Let's work in the IPython console to see how Python can function as a calculator. IPython is interactive, so at the in prompt, which is numbered, type an expression and press enter, and if there is output, it is printed on the next line at the numbered out indicator. This is called an REPL, or read evaluate print loop, because Python reads what is entered, evaluates it, and prints output if there is any, and then repeats the process in a loop. A semicolon at the end of a statement suppresses output, which can be useful if the output is a large quantity of data, like a large table. Printing "Hello World" is often the first thing you do when you learn a programming language. Hello world, I'm going to start coding. We have used the built-in function print from the Python standard library, which is a library that is automatically available and does not need to be imported. These are all the built-in functions in the standard library. We will come across quite a few of them in this video. Getting back to print, we see that it has a character string as its argument. A string is a data type in Python with the code str. The string is between single quotes. A string can be entered as what is called a literal, which is a sequence of characters or numbers in a format that is specific for each type of text or number. A string literal is written as text between single or double quotes, but don't mix single and double quotes. If you do, it raises an error. Raises is a technical term for indicating an error, just like a soccer linesman who raises a flag when a player breaks a rule. The type built-in function returns the type of an object, in this case of a string. Python has several data types for numbers. First, integers, written as literals as one or more numerals. Entering a literal produces it as output. The type of an integer is int. A minus sign gives a negative integer. Next, real numbers. A real number is represented and approximated in binary as a floating point number of type float. A float literal must have either a point or be written with a power of 10 with the exponent symbol, which is an e followed by a power of 10, or both. The point does not need numerals to the left or to the right as seen before. The point can float like this, all of which are the same number. E can be written as capital E, but Python uses lowercase e, so we will stick with that. The exponent can be negative, and so can be the mantissa. Python represents complex numbers with the complex type, which is a double-valued type with a real and an imaginary part, each of type float. The square root of -1 has only an imaginary part, written as the literal 1j. This uses j as engineers do. The literal cannot be written with j first. The real and imaginary parts are attributes of a complex number, accessed with the dot operator like this. As with e for a power of 10, capital J may be used for a complex number, but Python uses lowercase j, so we will stick with that. Those are the number types in Python: int, float, and complex. Now for a couple more types. The Boolean or logical type is bool, with only two values, true and false, with these literals. The type of these is bool, and they must start with a capital letter. The bool type is treated by Python as a subtype of int. False is integer 0, and true is every other integer. An interesting type is the none type, which has only one value, none. It is used in a case when no value is supplied or generated. So far in this video, we've seen 6 types. Let's look at the built-in constructor functions, which serve various purposes. For example, the int constructor function, with no argument, constructs a new int object with default value 0. Each type has its own constructor function with a default value. The default string is the empty string. We use the built-in len function to see its length, which is 0. For the other types, A constructor function can be given a value rather than using its default value. For example, a complex number can be constructed with int or float, real and imaginary arguments. Note that IPython prints a complex number in brackets. If one argument is supplied, the complex number has only a real part. Finally, a constructor function is used to convert an object of one type into an object of another type. This is called casting. To cast int1 to float1, use the float function with int1 as the argument, and vice versa. The str function casts its arguments to a character string, and the bool function casts 0, including complex 0, to false and anything else to true. Bool can even cast a string, but does not cast the character 0 to false. It only casts the number 0 to false. Python has a set of operators, so it can function as a calculator. For example, the plus symbol represents an arithmetic operator, the addition operator. Recall that a binary operator acts on two operands and maps to a result, in this case the sum. There is also subtraction, which produces the difference. The minus sign, actually the hyphen symbol on the keyboard, is also a unary operator, which takes one argument, which produces the negative of the number it operates on. This may not be clear here because it looks as if we have just typed the number -2. But if we type this, we have acted on the sum 2 plus 3 with a minus sign as the unary negative or additive inverse operator. Multiplication uses the asterisk or star symbol, which produces the product. There is no times by symbol on the keyboard, so the asterisk is used instead. The division symbol is a /. Note that dividing two integers produces a floating point quotient. For integer or floor division, use a double /, which gives the integer quotient. The remainder is obtained with the binary modulo operator, which uses the % symbol. The quotient and remainder may be obtained in one statement using the built-in function divmod. Python uses a double asterisk as a binary exponentiation operator, which takes integers and floats as operands, as well as negative numbers. But beware, Python does not know that you might want to raise 2 to the power 3 here. Use round brackets if that is what you intend. Round brackets take precedence over everything else. Arithmetic operators act on floats in the same way, and also on complex numbers. We can check the essential property of complex I. If operand types are mixed, Python automatically casts a type up from int or bool to float, and from float up to complex. True and false can be used as the integers 1 and 0, but you will probably never need to do something like this. In addition to arithmetic operators, Python has Boolean operators AND, OR, and NOT, which operate on Boolean values. The AND binary operator is true if both operands are true, and false otherwise. The OR binary operator is true if either operand is true, and false otherwise. And the unary NOT operator produces the opposite of its operand. Comparison operators, also known as relational operators, act on numbers and produce Boolean values, true if the comparison is true, and false if it is false. They are is equal, is not equal, is greater than or equal to, is less than, and is less than or equal to. Comparison expressions may be combined in Boolean expressions. For example, 2 is less than 3 and 4 is greater than 5 is false, because 2 is less than 3 evaluates to true, and 4 is greater than 5 evaluates to false. So the simplified Boolean expression true and false evaluates to false. Combining comparison expressions in this way allows complex conditions on numbers to be evaluated. There are also string operators, plus and star, which act in a special way. Plus concatenates or joins strings, whereas star copies a string in a concatenation. A string can only be multiplied by an integer, and if the integer is negative, the string becomes empty.